I'm Sujani, faculty in physics at Institute of Aeronautical Engineering, Hyderabad. Today we are going to see some numericals based on Hall effect. So before doing the numericals, let us have a quick recap of the formulae that we are going to use. So the first one that we are going to use is RH is equal to 1 upon Ne. So if I'm talking about electrons as the charge carriers, we have RH is equal to minus 1 upon Ne. And if it is due to holes, we have RH is equal to 1 upon Pe. RH here represents the Hall coefficient. N represents the electron concentration. P represents the hole concentration. And E is the charge of the electron. Now the second formula we have here is to calculate the value of RH using the Hall voltage. So VH into T upon B into I. RH is equal to VH into T upon B into I. RH is the Hall coefficient. VH here denotes the Hall voltage. VH is Hall voltage. Small t here represents the thickness of the specimen or the semiconductor. B here is the magnetic field, or we call it as magnetic field induction. And I is the current. I is the current. Then we are also going to calculate sigma. Sigma is the conductivity. Sigma is equal to N E mu E plus mu P. If we are writing a general expression for sigma, we write N E mu. But here in a semiconductor where we are seeing it is due to electrons as well as holes. Of course, if it is an N-type, the electrons are the majority carriers. But we are considering the mobility of the electrons as well as the mobility of the holes. So we write here sigma is equal to Ne into mu E plus mu P. What does sigma denote? Sigma is the conductivity. N here we have already defined electron concentration. E also we have defined charge of the electron. And mu represents the mobility. Mu is the mobility. And this suffix represents if it is E, electron. If it is P, it is due to holes. Then from the same formula, if we have to calculate the mobility, mu will be equal to sigma upon Ne. Because we want to find mu. So mu, we can take Ne onto the other side. So mu is equal to sigma upon Ne. Suppose N and E are not given. We know the Hall coefficient and we know RH is equal to 1 upon Ne. We can write it as RH into sigma. We can calculate mu knowing the values of conductivity and Hall coefficient also. And one more formula is, if you know the conductivity, you can find the resistivity. So rho is the resistivity you can get using 1 by conductivity. Here rho represents the resistivity. So all these formula will be very handy. They are very simple formula, and the numericals we are going to do are also very simple. But when you are applying the formula and calculating the value, your concept will become very clear. So that is why you need to do a number of numericals with different data so that your concept becomes very clear. So I hope with these formulae, we will move forward with doing the numericals. So first one, calculate the density of charge carriers of a semiconductor given the Hall coefficient as minus 6.85 into 10 power minus 5 meter cube per coulomb. So first write the data given. So what is the data given? RH is equal to minus 6.85 into 10 power minus 5 RH. We have to calculate the density of charge carriers N. So what is the formula we have? We know RH is equal to minus 1 upon NE. Now we are given RH, we have to find N. So using this formula, we'll write N is equal to minus 1 upon RH into E. So N will be equal to 1 upon minus and minus will get cancelled because the value of RH is negative. So I'll write 6.85 into 10 power minus 5 into E is a constant. The charge of an electron is constant. E is equal to 1.6 into 10 power minus 19 coulomb. E is the value of E. So now we substitute the value of E here, 1.6 into 10 power minus 19. You can use your calci to simplify this and you get N is equal to 9.124 into 10 power 22 atoms per meter cube. So the number of atoms per meter cube, we are calling it as the concentration of charge carriers or the density of charge carriers. We can get very easily. Next one. For a semiconductor, the Hall coefficient is minus 3.7 into 10 power minus 6 meter cube per coulomb and the electrical conductivity is 250 per meter ohm. Calculate the density and the mobility of the charge carriers. We need to first calculate the density, that is the charge carrier density, and then the mobility. So let us write the data given. We are given Hall coefficient RH minus 3.7 into 10 power minus 6 meter cube per coulomb. And then we are given the conductivity 250 per meter ohm. We have to calculate the density, current carrier density N, and also we have to calculate mu. This is what we have to calculate. So what are the formulae we are going to use? So knowing the value of RH, to calculate N, we will use the formula N is equal to 1 upon RH into E. What is E? Again, the charge of the electron, 1.6 into 10 power minus 19 coulomb. We will substitute that value here. So N will be equal to 1 upon 3.7 into 10 power minus 6 into 1.6 into 10 power minus 19. See here I am neglecting this minus because actually we have to write N is equal to minus 1 upon RH into E. So we have a minus here, we have a minus here. So I have written it as plus. Otherwise you may denote both the minuses here and then simplify. You get 1.689 into 10 power 24 atoms per meter cube. So this is giving us the charge carrier density. So once you get N, you have to find the mobility mu. So what is the formula for mu? Mu is equal to sigma upon Ne. Or we can also use sigma into RH. Both are fine. Once you find N, you can use sigma upon Ne. Or instead of doing that, you know the value of sigma, you know the value of RH. You can directly substitute. What is the value of sigma here? That is conductivity 250. And the value of RH 3.7 into 10 power minus 6. So this is 92.5 into 10 power minus 5 meters square per volt second. So that is how we are able to calculate the carrier density and also the mobility. Next one. Simulate the Hall voltage developed across the width of the slab of a metallic slab carrying a current of 30 ampere, subjected to a magnetic field of 1.75 Tesla, and the magnetic field is perpendicular to the plane of the slab carrying the current. The thickness of the slab is 0.35 centimeter and the concentration of free electrons is 6.55 into 10 power 28. So we are given the current 30 ampere, magnetic field 1.75 Tesla, thickness of the slab 0.35 centimeters, the concentration 6.55 into 10 power 28 electrons per meter cube. What we have to find? We have to find the Hall voltage. So how do we calculate the Hall voltage? Write the data first. In the data, first we write the current. I is equal to 30 ampere. And then we have the magnetic field B is equal to 1.75 Tesla. Then the thickness T is equal to 0.35 centimeter. So because we are doing the numerical, I told you we will always follow one system of units and we are following the SI system. So we need to convert this centimeters into meters. So this is 0.35 into 10 power minus 2 meter. Thickness. Then the concentration of electrons is given by N is equal to 6.55 into 10 power 28 electrons per meter cube. What we have to calculate is the Hall voltage. VH is equal to how much? So what is the formula we are going to use? We have the formula for RH is equal to VH into T upon B into I. We have already derived this expression. RH is equal to VH into T by BI. Now we want to find the Hall voltage. So we will rewrite it as VH is equal to RH into BI upon T. Now simply substitute the values for RH, BI and T. So RH is not given. We are given the concentration of electrons. So for RH, we will substitute 1 upon Ne. So we can write it as BI upon NET. Since the value of RH is not given, we are given the concentration. We are writing it as BI upon NET. So again, we will write the value of E here. E is 1.6 into 10 power minus 19 coulombs. So VH is equal to B 1.75 Tesla, current 30 ampere upon N, the concentration of free electrons, 6.55 into 10 power 28, and E 1.6 into 10 power minus 19 into T, the thickness, 0.35 into 10 power minus 2. So we get the Hall voltage to be 14.313 into 10 power minus 7 volts. This is a volt. So once you identify the data correctly, write the formula and modify the formula in the required form. Required form in the sense, write it in all known terms. Whatever data we know, we will have to write the formula in terms of the known data. And then the third step will be substitution and simplify. You can use the calci to simplify it, and directly you can write the answer VH is equal to and mention the units also. So voltage is always measured in volt. So each step will carry marks. So each step you will have to write very carefully. Next one. The intrinsic carrier density is 1.5 into 10 power 16 per meter cube. If the mobility of electron and hole is 0.13 and 0.05, calculate the conductivity. So the carrier density is given 1.5 into 10 power 16. Then mobility is given, mobility of electron and hole. We have to find the conductivity. So let us write the data. Data given. N is equal to 1.5 into 10 power 16. Then we have the mobility of the electron 0.13 and the mobility of the hole 0.05. We have to calculate the conductivity sigma. So what is the formula we have for sigma conductivity? Sigma is equal to Ne mu E plus mu H. This is the formula we have for sigma when we have both electrons and holes as the charge carriers. Both are having mobility. Then the conductivity is due to both. So we modify the formula and write it as Ne mu E plus mu H. Value of E, again we are taking it as 1.6 into 10 power minus 19 coulombs. So now it is mere substitution. N is 1.5 into 10 power 16 into charge is 1.6 into 10 power minus 19 mu E 0.13 plus 0.05. So we have 1.5 into 1.6 into 0.13 plus 0.05 is 0.18 multiplied by 10 power plus 16 and minus 19 will give us minus 3. So what you get here is 4.32 into 10 power minus 4. So this is the value of conductivity we are getting with the data given. Now one more. The intrinsic carrier density at room temperature in germanium is 2.37 into 10 power 19 meter cube per coulomb. If the electron and hole mobilities are 0.38 and 0.18 meter square per volt second, calculate the resistivity. It is similar to the previous question, but here we are going to calculate the resistivity. So write the data. Carrier density is given 2.37 into 10 power 19. So N is equal to 2.37 into 10 power 19. Then the mobilities are given. Mobility of electron and hole. Mobility of electron is 0.38. Then mobility of hole is 0.18. We have to calculate the resistivity, rho. So what is the formula? You may write it directly or we will write it in terms of known terms. So the formula we have for sigma is Ne into mu or Ne into mu E plus mu H. The value of E is 1.6 into 10 power minus 19 coulombs. So sigma will be equal to 2.37 into 10 power 19 into E, 1.6 into 10 power minus 19, and mu E plus mu H, 0.38 plus 0.18. So we can write sigma as 2.37 into 1.6. 10 power plus 19, 10 power minus 19, 10 power 0 is 1. So here we have 0.56. So this gives us 2.1235 ohm meter. This is the value of sigma, that is conductivity. But what we are asked to find is resistivity. So resistivity rho is nothing but 1 upon sigma, that is conductivity. Sigma here is conductivity, rho is the resistivity. So rho is equal to 1 upon sigma. So we do 1 upon 2.1235. So this is 0.4709 ohm meter. 0.4709 ohm meter is the value of resistivity. Thank you. We'll see you again with more numericals in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.